Yeah. Okay. All right, so today and tomorrow we're going to be reviewing some of the things that we talked about during the pre-test stuff that you guys took yesterday. Today it's mostly going to be fractions, decimals, and percentages, just different things that we can add, subtract, multiply, and different things you're going to be having to convert throughout the year. So this kind of just gives us a little head step, I guess, in front of what we're going to be doing when we actually start chapter 1. All right, so what I would like you to do in your notebooks every day, at least put the title down, section number when that applies might be helpful too. So right now you can just call it chapter P or preview or whatever you want to do, and then fractions, decimals, and percentages. As far as the goal, that's what we're going to be doing. So if you want to write that down, you can, but you'll figure that out as we get to the slides themselves. Good? All right, so we are going to start with some fractions today. Adding and subtracting fractions, which we talked about a little bit yesterday. Remember, we want to make sure you have a common denominator before you add or subtract. When you do have a common denominator, you're going to be adding and subtracting the numerators, and the denominators are going to stay the same. So let's start with this first one. If I have 6/7 plus 2/7. By the way, you don't have to write down all those little blurbs if you don't want to. If you feel like there's a little fun fact you want to put in your notes, that's fine. But at least the problems themselves I want you to put in there. If I have 6/7 plus 2/7, can anybody tell me what that would be? I heard somebody say 8/7. Good. Okay, so numerator, we're adding those together, gives me an 8. Denominator 7 and 7 stays a 7. So I have 6 pieces of something, another 2 pieces of that same thing, gives me 8 total pieces. All right, one right below it. I have 1/6 and 2/6. Can anybody tell me what that would be?
1/2.
It would be very good. Okay, you're one step ahead of me though. Before you get to the 1/2, what do you get? 3/6. Okay, so we add the numerators. Denominator stays the same, and then I love that you reduced it. We always want to make sure that if we have a numerator and denominator like this one, that they're divisible by the same thing. So in this case, they both have a 3 that divides evenly in. We can go ahead and simplify that and make it a 1/2. Okay, any questions? Awesome. So what do I do if I'm adding or subtracting and they do not have a common denominator like this? Remember how to make that common denominator. Okay, so we can multiply by whatever we want as long as we multiply by the same thing on the top and the bottom. So for example, you said 10. You want both the denominators to be 10. That's good. So what could I multiply 5 by to make it a 10? 2. Okay, I can't just multiply the bottom by 2. I have to multiply the top and the bottom by 2. Okay, so I'm going to multiply the top by 2 and the bottom by 2. Which means that's going to be 4/10. And then I have that minus 3/10, which I'm not going to change. If I have 4/10 and I take away 3/10, my final answer is 1/10. Good. And that does not reduce. Final answer. What if I have 1/2 plus 5/3? 1/2 plus 5/3. How about we start this? What would the common denominator be? Maybe even the least common denominator would be great. 6 is the least common denominator. It's the smallest number we can find that both 2 and 3 divide evenly into, or 2 times something and 3 times something both would give me a 6 if I use whole numbers. So what would I have to multiply 2 by to make it a 6? 3, so I have to multiply the top and the bottom by 3. What about the second fraction? I have to multiply this guy by what? 2. Times 2 times 2. All right, so it looks like in my first fraction, I have a 3 on top and a 6 on the bottom. In my second fraction, I have a 10 on top and a 6 on the bottom. 3/6 and 10/6 gives me 13/6. Okay, I want you guys to take a minute with your new partner and try the one at the bottom together. I'll give you a minute. Make sure your answer is reduced completely. Okay, what is the least common denominator? 12 is the least common denominator. Did anybody use a different common denominator? That's not the only way you could do this problem. 24. Yeah, when in doubt, take the two bottom numbers and just multiply them together. That's always going to be a common denominator. Now, it won't be the least one, which means you just add an extra step. Potentially at the end, you're going to have to reduce something, but you will definitely still get the same answer, so that's fine. So if you had 12, 24, or any multiple of 12, 36, 48, etc., any of those would work. All right, so I'm going to use 12 because that's the smallest one. So I'm going to multiply top by 2, bottom by 2 here. That gives me 10 twelfths. And then I'm going to multiply this guy by 3 to get the 12 on the bottom. 9 twelfths, which gives me 1 12th. If you don't have 1 12th on your paper, maybe double check, see if your number is reduced to 1 12th. Like if you have 2 24ths, for example, that would reduce to 1 12th, and that's the same answer. Okay? Any questions? Thanks, subtracting fractions. Nothing crazy. All right. Multiplying fractions is even easier because you do not need a common denominator. In order to multiply fractions, all you do is multiply straight across. You multiply the numerators together, you multiply the denominators together, and again, you reduce. Our first problem, 2/5 times 4/8. What am I going to get in the numerator? 8. Wonderful. 2 times 4, 8. There we go. Denominator, I have 5 and 8, which multiply to 40. 8 and 40 definitely have something in common. What are those both divisible by? 2. Okay, now 2 is not the biggest one, but that's okay. Let's divide them both by 2. And you see you can just keep simplifying, right? If I divide it by 2, I have 4 over 20. Is that divisible by 2 again? Yes, so 2 tenths. Is that divisible by 2 again? Sure. 1/5. Now, a way to kind of shorten that work is if you look at 8/40ths, the largest thing that divides into both of those numbers is 8, actually. If I do 8 divided by 8, I get 1. If I do 40 divided by 8, I get 5. Now, you can see it gives me the same answer either way, but if you see those larger common divisors, you can maybe save yourself a couple steps. Okay. All right. What about the one on the bottom? 3/2 times 1/3. What am I going to get on top? 3 on top. What am I going to get on the bottom? 6. And it reduces to 1/2. Anybody ever showed you this before when you're multiplying fractions? If you have something similar, common factor on the numerator and denominator, they just cancel. So that gives me 1/2 that I'm left with. Okay, so it's a little shortcut sometimes. Any questions? Multiplying fractions. Awesome. Dividing fractions is like multiplying fractions. We're going to keep the first fraction the same, and instead of dealing with the second fraction as it's written, we're instead going to multiply by its reciprocal. Does anybody remember what reciprocal means? Say flip it, right? Upside down? Okay, numerator goes to the denominator, denominator goes to the numerator. Okay, so I'm going to rewrite this problem. Anytime I see division, instead of dividing by a fraction, we're going to multiply by its reciprocal. So for this first one, I'm going to keep that 1/8. And instead of dividing, I'm going to change it to multiplication. And then we're just going to flip that second fraction, use its reciprocal, 5/2. And now it's exactly the same as the problems we saw on the last page. We're just going to multiply straight across. So on top I get 5. On the bottom I get 16. Does 5 over 16 reduce? All right, you guys try the one at the bottom with partners. Give you a minute. Multiplication knowledge around the world, maybe. 8/3, 7/5. If I flip that second one, what do you get on top? On the bottom? 15. Is there a common divisor there? Anything that they both have in common? I don't think so. Here's a quick way to check. Does 3 go into 8 or 7? So it's not going to go into 56. Okay. All right. So that's all we can do. And by the way, your calculator, when you guys all have the graphing calculators, will automatically reduce fractions for you. That's one of the things we're going to talk about once everybody has them. We're going to show you how to do that. So if you're not sure, because especially sometimes they're going to get really, really big. Like if I have 185 over 37, that's maybe one you don't know all the factors of 185 off the top of your head. So the calculator is going to be helpful for that. Okay. All right. Next, converting into a decimal. We need a calculator for this one. If you do not have a graphing calculator or your own calculator with you, I have some of these basic red ones that you guys used back in the day, probably. So maybe send one person up from your group to grab one if you need them. Just grab that one. Sounds good. Have you guys started shopping for the 84 calculator yet? Maybe kind of, sort of. Do we like have one on order, or we have an idea of how we're going to get it, or we have like a plan set in motion? By the end of next week, you need it. So, and actually we don't even have school on Friday, so by Thursday next week, you need to have it in your possession. Next Friday, you do not. It's a 4-day weekend. It's Labor Day weekend. So you guys always have, well, the teachers have school on Friday. We have a work day, but then everybody has Monday also. So technically it's the 30th, it's 29th, but that means you have a week and a day to find that calculator. Okay, so if you need to order it off of somewhere, start looking on, remember I said eBay, Craigslist, Facebook Marketplace. A secondhand one is just as good as a brand new one in most cases. So, all right, converting to a decimal. When you have a fraction, what does that bar mean? Division. That's all we're doing in our calculator. So if I do 6, maybe, divided by 7, I get, what's the decimal? What's it? 8571, etc., etc. Yeah? No? Yes? Good? Okay, close enough. All right, 2/5 is going to be a little bit easier. If you do 2 divided by 5, you get 0.4. Okay. Converting into a fraction. So this is going to look a little different depending on what calculator you have in front of you. If you have the red calculator, you're going to type in the number, so 0.625. Then you're going to hit the yellow button, the second button, and then you're going to hit the button that's diagonal from that that says PRB. Right above it, it says F to D. That's what it means, fraction to decimal, decimal to fraction. Okay, so if I hit second, and I hit the PRB button, hit enter, everybody should see a 5 and then a slash and then an 8 on the red calculator. Yes? Okay, if you have a graphing calculator, type the number in, 0.625, and then I want you to find the math button on the right, or on the left, excuse me, hit that. Math, it's kind of towards the top. And then enter, enter. Math, enter, enter. You should see, yours probably shows up and it looks like an actual fraction in the graphing calculator, 5/8. Everybody able to get it on one or the other? Okay, all right. Try the next one on your own. Convert it to a fraction. So in the red calculator, type it in, second probability, enter. On the graphing calculator, type it in, math, enter, enter. What do we get? 17/20? Is that right? Okay. Any questions? Fraction to decimal, decimal to fraction. Helpful and easy, hopefully. Okay. Convert into a percent. Before something can be a percent, what does it have to be? A decimal. 2/5 we said was what decimal? We did it a minute ago, 0.4. Okay, and then you get 40% by doing what? Anytime we have a decimal to convert to percent, 2 places to the right. Good. So if I have 0.4, if I move it 2 spaces to the right, I get an extra little 0 there, 40%. So 0.28 would become what percent? 28%. Good. You guys do the 2 at the bottom. Convert them into a percentage. Use the calculator if you need it probably here to get that decimal first. Okay, so 4/9, is that 0.4 repeating? Yeah, so 0.444-ish. So it's about 44% if I was going to round to the nearest whole number there. And then this guy here, we really don't have to round. We should just have 57.8%. That's exact. Questions? Are we doing okay with this? Am I blowing anybody's mind yet? We're fine? Just a little bit? Not too bad? Okay. All right, convert to a decimal. So how do I go backwards? Take it 2 places to the left. So right now, if I have 65%, it's 65.0% technically, right? So if you're not sure where the decimal is, it's right there. So I want to move it 2 spaces to the left, so it would become 0.65. And if you want to throw a 0 at the end of it, go for it. So what would 112% be? Good, 1.12. Again, that decimal originally, when we see the percent, is after the 2. In that problem, move the 2 spaces to the left, makes it back to a decimal. Okay? Good. Nothing crazy. Okay. My favorite now. We always have to end with a word problem. Welcome to my class. All right. You want to buy $50 for a pair, or you want to pay $50 for a pair of shoes, and it just went up for sale 20% off. What is the price that I'm going to pay for these shoes? All right. When you have a word problem, I do not want you to write this down word for word in your notes. What I do want you to write down is the important information that you need to pull off of this. What's important information that we need to write down? Give me one thing. Okay, so the shoes are $50, $50 for a pair. Give me another piece of information we need. And they are 20% off. How much will I pay? Now here's the important thing. When you buy something and it's 20% off, are you paying 20%? You are not. What percent are you actually paying? You are paying 80%, right? Where does that 80 come from? 100, take away that, okay? Anytime you have a discount, we do 100 minus, meaning we start with 100% of something, a full amount, and we take away the percent that is the discount. So in this case, 100 minus 20 is 80%. So we need to figure out what is 80% of $50. Do you remember what the word of means in math? It means multiplication. So let's take this one step further. 80% is what decimal? 0.8. Of means multiplied, and 50. That's your calculation. 0.8 times 50. In your calculator, what do you get? $40. Okay, this is not the only way to do this problem. Another thing you could do is you could find 20% of 50, which is 10, and then you could do the subtraction. 50 take away 10 would also give you 40. In my opinion, though, that's a little bit more difficult because you have that extra subtraction at the end. This, you can just do it in one step, okay? All right. Nick works at Bridgestone, so he gets an employee discount of 40% off tires. How much will he pay for the tires that are priced at $530? Try it with your partner. 1, so he gets an employee discount of 40% off tires. Write down underlying important information to start. How much will he pay for tires that are priced at $530? If he gets 40% off, what percent is he paying for the tire? That's what we care about, right? 60%, so we multiply by 0.6. Oop, 60%. 0.6 times 530. What do we get, guys? What was it? 18. Even? No pennies? Good? Questions? Okay. Last problem. Tommy buys school supplies at the store that total $52, but there is a 7% sales tax. What is his total after tax? Sales tax is different, right? It's not a percent that we're discounted, it's a percent that we're adding on. So let's kind of think about what we did with the discount. When we had a discount, we took it away from 100. So if we have a tax, an increase, we do what? We do the opposite. We add to 100. So I'm going to start with 100% of something. And if I add on 7%, I have a total of what percent? I have 107% that we're paying for my school supplies. 107% is what as a decimal? Move it 2 spaces to the left. So 1.07. The 1 represents the 100. The 0.07 represents that extra percent we added on. And then again, of, so times $52. Type it in your calculator. Tell me what you get. Why is what? The 1 represents the original 100%. That's going to keep that $52. Here's the other way to do it. You could do 52 times 0.07 and then add that back on to the 52. But that requires 2 steps. So keeping the 1 there does it all in 1 step for us. They're both the same calculation. Did anybody else think of it that way? They found 7% of 52 and then they just added it on to 52. Okay, but again, we can shorten it a little bit if we just put the 1 in front of it and do it all at once. So 1.07 times 52, I got 5564. Does that sound good? All right, so that is our lesson for today. Fractions, decimals, percentages, sales tax, discounts. Any questions? You have no homework tonight. Yay! How about you try to find a calculator tonight? I'm broke.
Yeah.
Find an alternative if you have a need for one and we're not able to get one. Talk to me after class and we will figure it out. Okay? All right? And then don't forget a couple other supplies on the board. Anytime you have these, I will take them, guys. Okay? And then I'll do the cell phone lotto for those of you that have your phone over there.